Welcome to the Explainer. Today, we're jumping headfirst into the Zerai Self-Sovereign Identity ledger. We're going to decode all those cryptic hashes and transaction IDs and turn what looks like total chaos into a really clear picture of how verifiable trust actually works. You know the feeling, right? You pull up one of these explorers and you're just hit with this wall of text. Long strings of characters, weird transaction types, hashes. It honestly feels like you need a secret decoder ring just to understand what's going on. Well, if you've ever felt that way, you are definitely not alone. But here's the thing. Buried inside all that complexity is a super powerful, really revolutionary idea about how we can handle digital identity, who owns our data, and what privacy can look like in the future. So that's what we're going to do right now. We're going to crack this thing open piece by piece and translate the Ziraai SCI Explorer from that alien language into something that makes perfect sense. Let's dive in. All right, first things first. What is this ledger even for? The most important thing to know is that it is not a database for storing your private information. The best way to think about it is like a giant, public, digital bulletin board. It's a place where anyone can go to post and verify the rules of the system. And this whole system is built on a really simple idea called the trust triangle. You've basically got three main players. First, there's an issuer, let's say the Ministry of Agriculture, who creates a digital certificate. Then you have a holder, like a farmer, who receives that certificate and keeps it safe in their private digital wallet. And finally, you have a verifier, maybe a bank, who needs to check that the farmer's certificate is legit. Now this right here, this is the absolute core principle, the magic trick of the whole system. Remember that public bulletin board? It's only for public information. Things like public IDs and those rule templates. Your actual personal data, your name, your farm size, the details of your certificate, that stuff never gets posted on the board. It stays completely private, with you and only you. Okay, so let's follow a story to see how this works. Picture this. The Ministry of Agriculture wants to start issuing digital organic certifications. The very first step for them, before they do anything else, is to publish the template for that certificate on the public ledger for the whole world to see. And in this world, that template has a specific name. It's called a schema. Just think of it like a blank form you download online. It doesn't have anyone's personal info filled in. It just defines the empty boxes that need to be filled in later, like a spot for farm name or date of issue. And we can actually see a perfect example of this right in the Zerai Explorer. If you look at transaction number 8, the type is schema, the name is organic certification, and boom, right there it lists out all the required fields, farm name, owner's name, and so on. This is now a public, unchangeable rule that anyone can check against. But hold on a second. Before the ministry can just post a new rule like that, it needs its own official identity on the ledger, right? I mean, how does anyone know the ministry is actually the ministry? How do they prove they have the authority to create these rules in the first place? Well, that's where something called a decentralized identifier, or a DID for short, comes into play. A DID is a unique public ID that an organization, like our ministry, creates and controls themselves. It's all backed by cryptography, which lets them digitally sign their transactions and prove who they are without needing a central login system like Google or Facebook. So when you're looking at the Explorer and you see a transaction with the type NIAM, you'll see a bunch of them at the top. That is exactly what's happening. A new organization is essentially raising its hand, introducing itself to the network, and publishing its new public DID and its specific role for everyone to see. And it's important to know that not all these DIDs are created equal. They have different roles, kind of like job titles in a company. A trustee is like the CEO with the highest level of permission. A steward is like HR. They can help onboard new users. An endorser, which is the role our Ministry of Agriculture has one specific job, to publish those schemas and credential rules we just talked about. All right, so we've got the who, the public DIDs, and we've got the what, the public schemas. Now we can finally get to the fun part, zooming in on one of those cryptic transactions and figuring out what all those hashes and IDs really mean. This is the big question, isn't it? What are all these crazy long strings of letters and numbers? It looks like a cat walked across a keyboard, but I promise you it's not random at all. Every single one of those strings has a very specific and very important job. Okay, let's break it down. First, you have the transaction ID. That's easy. It's just the unique street address for this one entry on the ledger. Simple. Next is the digest.
Think of this as a unique digital fingerprint of the contents of this one transaction. If even a single comma changes, that fingerprint changes completely. But the root hash, now that is the key to everything. It's the digital fingerprint of the entire ledger book at the exact moment this transaction was added, linking everything that came before it together. So this gets to that big question. How does this connect like a chain of blocks? Well, that's the interesting part. This kind of ledger doesn't actually bundle transactions into blocks the way Bitcoin does, but it achieves the exact same goal of being impossible to tamper with. That root hash we just talked about is the magic link. It cryptographically proves that this new transaction is part of an unbroken historical chain, making the whole ledger tamper-proof. Okay, deep breath. We've gone through DIDs, schemas, hashes, and root hashes. You might be thinking, so what? Why go through all this cryptographic trouble? And the answer, the huge payoff for all of this complexity, is one simple word: privacy. Because all the rules of the game, the issuer's public DID, the credential schema, are all posted on that public bulletin board, it means a verifier can check if your credential is valid without ever having to see your private data. Think about that. Because the rules are public, you don't have to show your personal data to prove you're following them. And the way this happens is through a bit of cryptographic magic called a zero-knowledge proof. The farmer's wallet can generate a tiny, elegant mathematical proof. This proof basically says, hey, I can prove to you that I have a valid organic certificate that was signed by the ministry's public key, and it follows the public schema on the ledger. The bank can check the math on that proof, and it's perfect. But here's the amazing part. The bank learns that the farmer is certified, and nothing else. Not their name, not their farm size, not the date it was issued, zero extra knowledge. It's brilliant. So let's pull all this together. If you're going to remember anything from this, remember these 4 things. 1, the ledger is for public trust, not private data. 2, DIDs and schemas are the public rules of the game. 3, all those crazy hashes are what create a tamper-proof, verifiable history. And 4, the whole entire point of all of this is to prove who you are and what you're allowed to do, all while keeping your personal information safe and secure. And that really leaves us with a final, pretty exciting thought to chew on. This technology is so much bigger than just ledgers and hashes. It's about building a digital world where trust doesn't automatically require surveillance. So the question is, if you can prove things about yourself without constantly having to hand over your personal data, what kind of world does that unlock? What new services and interactions become possible?